The Sahara Desert looks like a golden sea from above. We see endless dunes, many blue and green oases, and a huge black spot that covers an area of 17,000 square miles. Wait, what? What is it? It's a pretty gigantic territory, but why have we rarely heard of it and never seen it in movies or documentaries? Perhaps it appeared recently. Oh no, this black spot is millions of years old. Let's go down and explore the area. This place looks flat from above, but it's extremely uneven. There are black hills, slopes, and strange, tall cones everywhere. Some of them reach a height of more than 330 feet. It's higher than the Statue of Liberty, and the highest peak reaches about 3,900 feet above sea level. All these formations seem to be burnt out. This whole area resembles a giant testing ground where something big was blown up or where a large-scale fire burned. In some way, it's true. There was a fire here, not on the ground, but under it, and then it burst out. This entire territory is covered with molten lava. It came out of the ground and spread in different directions, burning everything in its path. Then, a new portion of lava came out and solidified on top of the previous layer. And so, with time, the lava formed a hill, a cone, and all the mountains located there. So, turns out this place is covered with small volcanoes? Kinda. There are about 150 of them. They're all extinct, and they're not exactly volcanoes. This place is called the Harouge volcanic field. But the volcanoes here don't look the way you imagine them. Here you can find different types: small vents, chimneys, and even shield volcanoes. Do you remember what shields look like in historical epic movies about ancient Greece or Sparta? These are round, flat plates with a smooth protrusion, so shield volcanoes look kinda like these inverted shields. They don't turn into a hill or a mountain because the lava coming from these volcanoes is low viscosity, more fluid, and consists mainly of basalt. It spreads further than ordinary lava and takes longer to cool. As a result of such lava eruptions, vast and massive structures appear much wider and lower than ordinary volcanoes. Some of the volcanic rocks here are up to 6 million years old. The most recent eruptions occurred only a few thousand years ago, so it's quite safe to wander around here and take photos. Probably. But why are there so many volcanoes here? Most volcanoes on the planet appear along fault lines crossing the Earth's tectonic plates. Imagine that our planet is like a jigsaw puzzle. Fault lines are the places where the puzzle pieces are attached to each other. When seismic activity occurs, red-hot magma comes out of those cracks, and at that moment, a volcano appears. Okay, so the Harouge volcanic field is a huge fault, right? No. The strange thing is, there's no fault line here. Moreover, it isn't even located next to any of those fault lines. Volcanoes here have a rather unusual origin. For some reason, a huge magma reservoir formed under this area, filled with a surge of molten rock, and there was so much of it that it began to bubble out from different spots. These were not explosive eruptions like those of ordinary volcanoes. Magma here poured out smoothly from numerous vents, turning the ground a dark, coal-black color. All the volcanoes here are extinct, but even if they were to awaken, it wouldn't be a sudden disaster. You'd most likely have time to escape. Okay, now let's move to the Karakum Desert, which is located in Turkmenistan. This desert covers about 70% of the country's territory. It's 135,000 square miles of sun-scorched, barren land. Even if you wander through these hot plains, valleys, and ridges for several days, you still won't leave this desert. But if you go to the north-central part of the desert, especially at night, you can see something fascinating. Already from afar, you will see a bright pillar of light, as if someone started a large-scale fire. You come closer and see a fantastic sight, a huge pit with bright flames. This place is called the Darvaza crater, and it's not a volcano. The fire has been burning here at night and during the day for weeks, months, even years. This huge pit burns 24/7 and attracts a lot of tourists. Nobody knows for sure how this crater formed, but the most popular story says geologists came here in the early 70s to drill for oil. They got to work, but the ground collapsed beneath them. 3 sinkholes appeared here and they started leaking methane. In small quantities, this gas is safe. It's used as fuel, burning in gas turbines and steam generators to produce electricity. In everyday life, this gas helps to heat houses and prepare food. But in large quantities, methane can cause health problems. It's colorless and odorless, and you may not notice that you're breathing it in. Methane is non-toxic, but it has a suffocating effect, which can lead to serious physical damage. Also, a methane leakage can harm the environment because it's a greenhouse gas. Methane emissions can lead to an increase in global temperatures and the greenhouse effect. So, let's go back to our geologist in Turkmenistan. You know those scenes where a fire hydrant breaks in the middle of the city or a pipe bursts and the streets flood with water? Those geologists had a similar accident with methane. A huge amount of gas began to seep from under the ground, and something had to be done about it. You're in the middle of a desert next to a huge pit where dangerous explosive gas is leaking out non-stop. What would you do? Set it on fire, of course. Scientists thought the fire would soon burn all their gas reserves and everything would be fine. They set it on fire and started waiting. An hour? A day? A week? A month? Years passed, but the gas continued to burn, and it was much better for the environment than invisible seepage. This place began to attract tourists and geologists from all over the world. Many scientists wanted to look at the eternal fire to examine it, and some of them did. In 2013, a Canadian researcher came there and found out that no one really knew how that funnel had formed. Local geologists said that the crater had formed in the 60s, but people began to talk about it only in the 1980s. Now it's impossible to find exact information about the origin of the fire pit because it's classified. Why? Good question. If you have the money and desire to go to Turkmenistan to see the Darvaza crater, don't rush to do it. After lots and lots of years, the crater seems to be calming down. But why? Has all the methane run out? Nope. The authorities just stepped in and tried to stop the leak. In simple words, they found a way to turn off the valve. Now, in satellite images, you can see that the fire is almost out. On the one hand, it's sad that now you won't be able to see it with your own eyes. But on the other hand, the number of fires in this region has decreased threefold. Okay, splashes of fire and magma in the middle of hot dunes don't seem strange. What about active volcanoes in the middle of icy plains and endless snow? On the territory of West Antarctica, scientists have discovered 91 volcanoes hidden under a 2.5-mile thick layer of ice. This makes Antarctica home to the world's largest volcanic ridge. All this ice is putting a lot of pressure on volcanoes and possibly holding them from erupting. But as we know, the temperature is rising all over the world, and the ice is melting. If it loses a lot of mass, it can trigger the volcanoes, which will then melt even more ice. This will lead to higher sea levels and many other problems. But let's talk about this in another video.
You find yourself in Africa, land of unique wildlife, home to a great variety of cultures and languages, and, first and foremost, host to the world's largest hot desert, the Sahara. It's daytime, and you are thirsty for some water and shade. You've been walking for days, trying to find one of those precious-looking oases. You feel you're near, but the horizon just keeps stretching and stretching. Your mind is tired, and your body is feeling all the heat. It's like you've eaten a full plate of hot pepper and then some more, judging by how much you're sweating. And when I say hot, think 100 degrees Fahrenheit hot, on average. No wonder this is happening. After all, you find yourself in the world's biggest hot desert. Now I say hot desert since the biggest deserted landscapes are actually the cold ones, located in Antarctica and the Arctic. I see Antarctica's frozen desert is more or less the size of 1 million LAXs. Yep, the Los Angeles International Airport. The Arctic Desert is just a bit smaller than that. Now, in case you don't know, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way over to the Red Sea. It occupies an area large enough to place approximately 100,000 Disney World theme parks side by side. According to scientists, its boundaries are expanding. Deserts usually form in the subtropics because of what's called Hadley circulation. The air rises at the equator and descends into the subtropics. This circulation of air has a drying effect, which helps the formation of desert landscapes. Since the 1920s, the Sahara is considered to have expanded by over 10%. How is this happening? Well, let's start from the beginning. You probably know the Sahara Desert as one of the most inhospitable places on Earth today. Just FYI, for a place to be considered a desert, it has to receive less than 4 inches of rain per year. Due to the very small precipitation index, deserts are usually dry and arid places. There is little humidity in the air, and daytime temperatures can go as high as 130 degrees Fahrenheit. Usually, there isn't that much animal and plant life because of the lack of water. But in the Sahara's case, it wasn't always like that. It may be difficult to imagine northern Africa without the tons of sand it has today. But about 20,000 years ago, the Sahara was actually one big oasis. Recent discoveries show clear evidence of what the scientists now call the Green Sahara. In the mid-1800s, a German explorer crossing the Sahara encountered some paintings and engravings that nomad artists had left behind. What he saw in those paintings looked nothing like his actual surroundings. Instead of an arid landscape with only camels and desert vegetation, the rock paintings depicted jungle animals like giraffes and hippos. There were even images of livestock and grazing animals such as cattle and sheep, something that seems impossible for modern-day Sahara. Artists usually draw what they see around them, so this finding really intrigued the German explorer. The drawings were so detailed that the artists must have had close contact with those animals. You can find this rock art spread out in the northern part of the African continent, from western Sahara to Saudi Arabia. Geologists soon took a keen interest in this and found the first clues to what this could mean. They have been able to confirm that, in fact, northern Africa was once much wetter. They found evidence from nearby deep-sea sediment off the coast of Mauritania. Sampled cores of underwater sand and mud, known as Saharan dust flux, show geologists that, indeed, a green Sahara was possible. The more dust is blowing off of the desert and into the bottom of the ocean, the drier the climate in the region. The sediment cores show that there was much less dust, only half as much, coming off northern Africa during the humid period. This period has to do with Earth's natural cycles. Normally, the Earth rotates at a tilt of 23.5 degrees, but this angle is not consistent and changes over time. Earth's tilt is responsible for the amount of sunlight each hemisphere receives. It affects several ecosystem functions on the planet. During the time of the Green Sahara, the Earth received between 4 and 8% more sunlight than it does today. So, when the Earth tilted about 20,000 years ago, the northern hemisphere received more direct sunlight, which affected humidity levels in the region. As the northern hemisphere got warmer, this affected monsoon activity, more specifically, the West African monsoon. Monsoons are wind systems that affect a region's rainfall index and humidity levels. As a part of the globe gets warmer, it allows for more air to rise. It combines with the wind to draw moisture up into the atmosphere. Little by little, northern Africa also became wetter. The increased moisture made the Sahara so wet that there were actual bodies of water in the region. As vegetation grew, the plants held onto moisture better than bare sand could. There is evidence of natural basins throughout the Sahara and lakes so big they would fit all of the U.S.'s Great Lakes inside of them. Archaeologists uncovered evidence of vibrant societies in what are now arid areas. It looks like ancient cultures were able to take full advantage of the African humid period. According to researchers, the human population peaked across the Sahara about 9,000 years ago. There are traces of fireplaces, hunting tools, fish hooks, and even mounds of fish bones. Records show that there have been over 230 green periods over the span of 8 million years. Solar radiation is always changing due to natural orbital cycles. That's why Earth will most certainly see another green Sahara moment. It might be thousands of years from now, but it will happen. The same way the Sahara turns green, it turns yellow again. Let's put it like that. All it takes is a significant axial tilt and a few years of readjusting. However, another phenomenon is calling the attention of scientists now. Recent studies by the National Science Foundation from the University of Maryland show the Sahara has expanded 10% over the past 90 years. This phenomenon is called desertification, which literally means fertile land turning into desert land. The Sahara Desert is now advancing into the semi-arid region of Sahel. In 1950, this region was home to 31 million people. Today, its population is over 100 million people. This rapid population growth has largely contributed to the Sahara's expansion. Farmers that were once nomads began settling down. Land usage grew more intense, aiding in weakening the soil. The demand for food has caused an overcropping of the land, so even more of it is turning into the desert now. The study also shows that natural climate cycles can affect rainfall in the Sahara and the Sahel. Scientists affirm that all deserts fluctuate, not only the Sahara. A desert's boundary may expand in the dry winter and contract during the wetter summer. South of the Sahara lies the Chad Basin. It is a natural body of water that now serves as an indicator of the Sahara's expansion. The Chad Basin is located in the region where the Sahara is advancing southward. An atmospheric and ocean expert from the University of Maryland explains that rainfall has reduced greatly in the entire region. Due to reduced rainfalls, there is less water across the entire basin, and even Chad Lake is drying out. Just like the Sahara, the Atacama Desert in Chile, deemed the world's driest, is also expanding. It is located north of the city of Santiago, and its southern border is expanding toward the Chilean capital. Because the climate is getting drier and drier here, the city of Santiago risks turning into an arid or semi-arid region itself. The once fertile valleys of local rivers that lived on agriculture and livestock for many generations are losing their revenues as Chilean land is turning into a desert. Since 2010, Santiago has received only a third of its annual rainfall. Outside of the city, farmers are digging holes in search of blue gold, or simply put, water. The situation here is very similar to that of Sahel. So tell me this. Were you as surprised as I was to find out what has been happening in the Sahara region? Feel free to share in the comments below.
Earth isn't a perfect ball, we know that. But the real mystery is miles beneath our feet. Way down below the crust, the planet has been cooling down for billions of years, just not evenly. The Pacific side loses heat faster, while the African side slows that loss by trapping it longer. That difference is why Earth stays restless, with earthquakes tearing the ground apart and volcanic fire breaking through the surface. Think of Earth like a massive engine that's been shut off. The outside cools first, but deep inside, heat lingers. That internal heat is leftover energy from when the planet formed, and it's been slowly trying to escape ever since. For a long time, scientists assumed Earth lost heat evenly in all directions. Hot in the middle, slowly cooling everywhere else. But when a team at the University of Oslo ran simulations that rewound the planet 400 million years and tracked where the heat actually escaped, they saw something very different. The cooling wasn't symmetrical at all. One side of the planet is doing it faster than the other. The difference is striking. The Pacific Hemisphere, the side dominated by the world's largest and deepest ocean, has cooled by about 50 degrees Kelvin, which is roughly 90 degrees Fahrenheit difference, compared to the Africa-Eurasia side. The reason is basically insulation. Africa and Eurasia are on a layered ancient continental crust. The Pacific side is the opposite. It's mostly ocean, resting on a much thinner crust where warmth escapes easily. Plus, the cold seawater on top pulls that heat out non-stop. Because the Pacific side is cooling so fast, the rock deep underground is getting heavy and sinking back toward the core. It's like a giant slow-motion conveyor belt that drags the Earth's crust down with it. Heavy materials sink. As it sinks, it pulls on the edges of tectonic plates, creating stress, trenches, earthquakes, and chains of volcanoes. Most of Earth's earthquakes and volcanoes happen in a giant loop called the Ring of Fire. This is where the ocean floor gets cold, heavy, and sinks deep into the planet. All that sinking rock travels thousands of miles down until it slams into a massive continent-sized structure sitting right near Earth's core. Scientists call this a blob because the heavy ocean floor is constantly falling on top of it. The Pacific blob is squashed flat and pinned down, sitting heavy and locked in place. But the other half of the world is doing the exact opposite. Under Africa, there aren't many sinking plates to act as a weight. Without that pressure holding it down, the African blob is free to grow tall and light. It pushes upward, lifting the ground from below and reshaping the entire continent. In fact, that rising bubble is already starting to tear the surface apart. In East Africa, a massive crack known as the Great Rift Valley is slowly opening up as the ground is pushed from below. Eventually, the pressure will become so high that Africa will literally split in two, allowing a brand new ocean to rush into the gap. There's a cool theory that suggests these blobs might actually be the remains of an ancient planet named Theia. Some researchers believe that Theia crashed into Earth billions of years ago, and while part of it broke off to form the moon, some heavy chunks might have sunk deep inside our planet. So, the reason our interior is so lopsided might be because we literally have pieces of a different world buried inside our own. But that's just a wild theory. Whatever their origin, the blobs matter because they help split the planet into two different behaviors. On the Pacific side, cold slabs keep sinking down and piling up. On the opposite side, heat builds up deep and pushes upward over time. One half is dominated by downward motion, the other by upward motion. And this imbalance doesn't stop at the mantle. It shows up at the very center of the planet because Earth's inner core is still growing. Liquid iron around it gradually turns solid and attaches to the core. This process doesn't progress at the same rate everywhere. One side of the inner core builds up faster than the other. This might sound like it should throw the planet off balance, but it doesn't. Earth's interior isn't rigid like a solid metal ball. Over time, stuff inside can gradually move around. Gravity pulls everything toward the center, helping everything get a bit smoother and keeping the core pretty round. But pretty round doesn't mean perfect. If you want a real example of how uneven Earth is on the inside, look at the Indian Ocean. Where there's more mass underground, gravity pulls a little harder. Where there's less mass, it pulls less. In the middle of the Indian Ocean, there's a huge anomaly called the Indian Ocean Gravity Hole. In that spot, Earth's pull is weaker than normal, so weak that it can't hold the ocean's surface up at the usual level. The water actually dips downward. You wouldn't notice it sailing through, but you'd technically be sitting about 300 feet lower than the rest of the world's oceans. It's an invisible valley in the sea caused entirely by missing mass deep inside the planet. However, Earth isn't the only world hiding a messy interior behind a smooth surface. Even the moon is like this. Over billions of years, Earth's gravity slowed the moon's rotation until it locked into place, keeping one face permanently pointed toward Earth. That's what we know as the near side and the far side. This mattered early in the moon's history. The near side always faced Earth, while the far side always faced deep space. That long-term setup affected how heat was stored and released inside the moon. When NASA mapped the moon's gravity using two spacecraft called GRAIL, they measured something called the love number. It's a value that tells scientists how much a planet or moon flexes under gravity. The moon's love number turned out higher than expected, which meant its interior was softer than it should be. When scientists looked closer at the gravity data, they found that most of this flexibility came from the side facing Earth. The moon's near side is softer and warmer deep down, while the far side is cooler and more rigid. Measurements suggest the near side mantle is significantly hotter and more volcanic. That difference shows on the outside. Because the near side was so hot and soft, ancient lava could easily punch through the crust and flood the surface. that created those big dark patches we see at night. On the other hand, the far side stayed colder and stiffer, so the lava never flowed the same way. Back on Earth, the Pacific has another quirk worth mentioning. Our planet isn't just spinning in place. It orbits the sun at over 66,000 miles per hour, and the entire solar system is moving through the galaxy like a car driving through a swarm of bugs. Over long periods of time, objects drifting in from deep space are more likely to hit the side of Earth that's moving forward. And because the Pacific Ocean covers such a huge stretch of that side of the planet, it naturally ends up catching more impacts than smaller oceans or continents. This creates a strange coincidence. The same hemisphere that is leaking the most heat from within is also the world's biggest graveyard for things arriving from the outside. Because it is so vast and lonely, space agencies even use its most remote coordinates as a spacecraft cemetery at a spot called Point Nemo. We deliberately aim satellites and massive space stations like Mir to crash right there. So the Pacific ends up taking the hits from two directions, by accident from the universe and on purpose from us. Earth is restless, continents drift, oceans open and close. In a few 100 million years, the map will look completely different. The Pacific is actually shrinking right now. Eventually, the Americas might crash into Asia, and a new ocean will have to take over the job of being the planet's main radiator and its front bumper. But for now, we should probably be thankful for that massive, chilly, unlucky ocean. For eons, the Red Sea has separated the continents of Asia and Africa. They're close enough to wave at each other, but far enough that moving between them requires planning. Ferries do the job, but it's time for something better. That's why engineers have envisioned an ambitious mega project of tunnels and bridges that will not only link the two continents, but also reshape the region forever. Millions of years ago, the Arabian landmass slowly drifted away from Africa, opening a watery scar that we now call the Red Sea. This place is famous for its crystal clear water that looks filtered even when it isn't, as well as for coral reefs that seem to be painted by an overachieving artist. Let's zoom in on one specific location, the Strait of Tiran. Every ship headed toward the upper ports squeezed through this one busy hallway. On the one side is Egypt, the Sinai Peninsula, rugged, golden, and sprinkled with resort towns. On the other side, it's Saudi Arabia, the Tabuk coast, where quiet desert hills stroll right down to neon blue water. The distance between them looks tiny on a map, almost like someone forgot to connect the lines. That's because the strait is only about 8 miles from peninsula to peninsula, close enough that on a clear day you can sometimes see the opposite shoreline. It's a busy gateway, and it's the exact gap designers want to turn into a direct road and rail link. So what are they actually trying to build? The idea is to create one continuous route between the Sinai Peninsula and the Tabuk coast. Engineers are still deciding whether it should be a bridge, a tunnel, or a hybrid, the combination of two. The problem is under the water. Near the shore, the bottom is shallow enough to support strong columns, but as you move farther out, the seabed drops quickly until it reaches about 900 feet. It's almost like walking off an underwater cliff. That sudden plunge is too deep for standard bridge supports. The design has to adjust to the landscape instead of forcing one shape across the whole gap. If they go with a bridge, the builders would place huge steel tubes called caissons on the seafloor. Think of them as giant metal buckets. Once they're in position, the water gets pumped out so crews can build a dry foundation inside. Concrete turns that space into a pillar rising from the seabed. The floating cranes drop long road sections between those pillars like puzzle pieces. It works well in shallow areas, but anchoring becomes difficult in deep waters due to high pressure, soft ground, and strong waves. Tunnels avoid this by going under the problem, literally. Crews can send tunnel boring machines called worms, or they can build submarine-sized tunnel segments on land and sink them into place. It's the same trick used in the Hong Kong-Zhuhai-Macau megalink, which proves it works even in busy, deep water. Now, people might look at the map and think, 8 miles? That doesn't sound so bad. In reality, it's nothing like tossing a giant tree trunk over a river and calling it a bridge. Cars, buses, and trains need those long, slow, friendly ramps that don't feel like a roller coaster. By the time you build those ramps on both sides, the whole thing could stretch to nearly 20 miles. That puts it in the same club as giants like the Chesapeake Bay Bridge Tunnel in the US or the King Fahd Causeway between Saudi Arabia and Bahrain. But it's not just the scale or unpredictable seabed that makes this intercontinental project challenging. There's also the climate. Temperatures regularly pass 100 degrees Fahrenheit. Concrete dries faster than planned, so crews have to cool it or work in shorter windows. Steel stretches in the heat just enough to make precise work annoying. And workers themselves cannot stand in direct sunlight for long without feeling like a baked potato. On top of that, the salty sea air chews through metal quicker than most people expect, so the whole structure needs tough protective layers and regular checkup. If this project gets the green light, you're looking at a timeline of several years. A good comparison is the Øresund link between Denmark and Sweden. It's only about 10 miles long and still took around 4 years to build, in an environment that is much easier to handle than the Red Sea. Then there's the price tag. Early numbers land around $4 billion, but that feels more like a starting guess than a final bill. If they run into problems, that figure will almost certainly climb. There's also one other problem that must be brought up: swimming right under the surface. The Strait of Tiran is home to dolphins, rays, sea turtles, and even sharks, including harmless reef sharks that glide around like they're protecting the beautiful, colorful corals below. These reefs aren't just decoration, they're some of the healthiest in the entire Red Sea. Scientists say that in parts of the northern Red Sea, some corals tolerate higher temperatures than many others around the world, which makes these reefs especially valuable from a climate resilience perspective. That means even a single mistake during construction could cloud the water with sediment, and that alone can smother corals like dust settling on wet paint. The same goes for noise, drilling, and ship movement. Reefs can't exactly move away if annoyed like fish can. Once they're damaged, it can take decades for them to grow back. That is, if they grow back. To avoid that, planners have to build in ways that keep the water as clear and calm as possible. Construction zones may need silt curtains to stop sediment from drifting away. Heavy equipment might have to avoid areas with dense coral clusters. Some sections could lean more toward tunnels instead of pillars to leave the seabed undisturbed. Every decision has to match the underwater map, not just the one on land. On top of that, the whole project would need constant supervision from scientists and inspectors. They would have to check how cloudy the water becomes and how marine animals behave during the work. If something looks off, the only responsible move is to slow down or change the method, instead of just rushing to finish faster and leaving the reef to pay the price. But if everything finally clicks into place, the payoff is massive. Right now, if you decide to skip the ferry and stay on land, the map punishes you. You have to loop all the way around the top of the Red Sea, through other countries on a drive more than 1,000 miles. All of that just to cross a stretch of water that is only a few miles wide at its narrowest point. It's like walking around the entire block just to knock on your neighbor's door. A permanent link would change this. Travel time drops, ports on both sides become easier to reach, and a drive from Africa to Asia suddenly feels as normal as crossing a long highway bridge. Not to mention the coolest part, which would be the view if they decided on the hybrid version. You begin your journey on the Sinai side, with the desert behind you and the Red Sea ahead. Instead of waiting in a ferry line, you roll onto a rising ramp while the water glimmers below. The road dips into a tunnel under a busy shipping lane, and before long, you're back in the sunlight on the other side, now on a different continent. The train version could feel even smoother. You find your seat, the doors close, and the train glides toward the crossing without any stop-and-go traffic. It slips into its own tunnel section, runs quietly under the sea, and pops back up on the Asian side before you have even finished scrolling your feed. For tourists, that could mean more resorts, more quick weekend trips, and a brand new continental hop that becomes a must-try experience. For delivery trucks, every hour saved is money earned. Even local towns would feel the change. They'd get more visitors, more trade, and bigger profits. A link like this doesn't just connect land. It connects economies, ports, and everyday life. And that's a giant opportunity, as long as the underwater world stays protected.
Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests, and the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era. But in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises. How come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse. "11,000 years ago, give or take, the most famous desert in the world, the Sahara, was all green and alive, with lakes, rivers, grasslands, and forests. Several thousand years later, it all changed. But then, in 1877, a Scottish businessman, Donald Mackenzie, got the ambitious idea to create a sea right in the middle of the Sahara Desert. Mackenzie thought he could dig a channel from a lagoon near Cape Juby in northwestern Africa south to a large island plain. He thought this area was very low, about 200 feet below sea level. If he flooded it with water from the Atlantic Ocean, he believed it would create a giant inland sea, about the size of 60,000 square miles. His idea was to use the new sea for commercial navigation to West Africa, which had plenty of valuable resources and markets with huge profits. Even though Mackenzie had never visited the Sahara himself, He read about other dry desert areas below sea level, like Tunisia and Egypt, which had salt lakes called chats. But the businessman was wrong about how elevated the plain was and didn't receive enough investment, so he didn't bring his project to life. A French geographer named François L. Roder and a diplomat who developed the Suez Canal came up with a similar idea a year later. Roder was inspired by Greek historian and geographer Herodotus, who mentioned the Bay of Triton in his writings. It's sort of an Atlantis of Africa, as there is no proof it really existed, and no one can tell where exactly it was located. The salt plain could have been the seabed of the Bay of Triton, and they could bring this sea back to life. So the French crew thought they could dig a channel from the Mediterranean Sea into a seasonal salt lake in present-day Tunisia. Water would flow into dry basins and create an inland sea. They were hoping it would be around 3,000 square miles in area and 75 feet deep. It would definitely require a huge amount of water. The new sea was supposed to turn the dry desert into a flourishing garden. The climate in the area would become cooler, and there would be more rainfall in the region. And here comes the best part for the French. They'd replace trade caravans with steamships and generate more profit. The cost of this project would be almost $1 billion in today's money. Some people got worried that this new sea would create swamps full of dangerous bacteria. The French authorities stopped the project when they found out that many areas that would be involved were not below sea level, and the plan was just impossible. Now, some people were also afraid it could tilt the Earth on its axis in a dangerous way, or cool down Europe to the point there would be a new ice age. But the idea lived on, and most recently, Egypt was considering flooding the Qattara Depression in eastern Sahara through a canal or tunnels from the Mediterranean Sea. Water would evaporate quickly because of the desert climate, and a controlled balance of inflow and evaporation would let them generate huge amounts of hydroelectric power. But the project involved using atomic power to carve the new channel, and it didn't come to be. Famous writer Jules Verne described the flooding of the Sahara in his final novel, Invasion of the Sea. In the book, the scientists didn't proceed with their plans to turn the desert into a sea, but an earthquake did the job for them. So if the book comes to life, we might go swimming at a new Sahara Sea resort in the future. Another massive flooding project has to do with Lake Erie in Australia. When it fills up completely, it becomes the largest lake on the continent. It happens only a few times a century, and when it does, the lake has the same salinity as seawater. When it dries up, it becomes extra salty. There was an idea to flood Lake Erie with seawater using a big canal or pipeline. It was supposed to make more water evaporate, and it could bring more rain to nearby areas. But when scientists did their math, they saw that the extra rainfall would be very small. It is so tricky because Lake Erie is below sea level, and the area gets really hot, so lots of water evaporates every year. This means salt would build up very quickly, and the canal could get blocked by all the salt. If a big canal sent water to the lake, it could create a small sea, but without removing the salty water, the lake would collect tons of salt every year. In 1930, several British scientists suggested freeing 100,000 square miles of the North Sea from water. Huge dams were supposed to stop the water, and rivers flowing into that sea would be diverted somewhere else through canals. There would be a railroad connecting London to Berlin and a bridge across the English Channel. Antwerp and London would keep their access to the sea, and Rotterdam would lose its busy port. This idea never became a reality, but quite recently, one Dutch and one German scientist came up with a similar project. Their idea is to build a dam that would be 295 miles long between North Scotland and West Norway, and another section between West France and southwest England. The scientists did some math and figured out that the project would cost somewhere between $276 and $552 billion. Sounds like a lot of money, but it could save around 25 million people living in 14 European countries from high water. So, if we spread that budget over 20 years, the cost would be 0.1% of their combined GDP. And although it looks like science fiction, we already have the technology to build something like that. The depth of the North Sea between France and England is hardly over 328 feet and is around 416 feet between Scotland and Norway. We can already build fixed platforms in depth over 1,600 feet, so it should be fine. This project would turn most of the North Sea into a huge freshwater lake with no tides, and it would mean huge changes in its ecosystem. Plus, it would become more expensive to ship goods across this sea. The fishing industry would lose huge amounts of money, and it would also cost a lot to build huge pumps to transfer all of the river water that currently flows into the North Sea to the other side of the dam. So, the best that scientists can do is monitor the situation and hope there won't be a need for such a dam. Meanwhile, a German architect and engineer came up with another huge dam idea in the 1930s. It was supposed to completely change the inside of Africa with giant inland seas. The plan was to build a huge dam on the Congo River where it flows through some deep, narrow valleys after joining with the Kwa River. This would create a massive lake that would be bigger than the states of California, Nevada, and Oregon combined. Once this giant lake filled up, it would overflow into another river, which would then pour into the Sherry River, one of the rivers that feeds Lake Chad. Lake Chad would grow much larger, just like it was believed to be 10,000 years ago. The water would flow from the lake through Algeria and Tunisia right into the Mediterranean Sea. This new river would be big enough for ships to travel. It could replace trains or planes and would make it much easier to move goods and people across Africa. Back then, people didn't think much about how this could hurt nature and focused on how it would help the economy.